Let's jump right in. Today, we are exploring a truly fascinating explainer that sits right at the intersection of deep metaphysical philosophy and highly practical computer science. We're going to see exactly how abstract, ancient concepts about existence perfectly merge with the mechanical architecture of a modern tree database. It sounds a bit like science fiction, I know, but it's very real, and it has absolutely profound implications for how we understand computation and time itself. Here is a quick roadmap of where we're headed. 1. The code and the runtime. 2. The June 19th synthesis. 3. Inside the seed tree DB. 4. Triggering the SMS event. 5. The math of thisness. And finally, synthesizing the ephemeral.
Section 1. The code and the runtime, a metaphysical divide.
Okay, let's start by establishing the foundational problem we're looking at today. For centuries, philosophers have wrestled with the divide between that which is eternal and static and that which is fleeting and temporary. Well, in computer science, this exact same grand philosophical divide exists right inside our machines. To understand this, let's borrow two Latin terms that have been brilliantly repurposed for digital architecture. First is universali. Think of this as the eternal, unchanging nature of a static, pre-runtime JavaScript file. It's universal. The second term is hakietate, which translates roughly to thisness. In our context, this is the fleeting, highly ephemeral reality of a live runtime instance. If we use a biological metaphor, universali is the organism's DNA blueprint sitting perfectly safely in a cell, while hakietate is the brief, active, messy life actually lived by that organism in the real world.
The contrast between these two states is stark. On one side, you have dormant algebraic instructions lying perfectly still in a static file. They're eternal, sure, but they aren't actually doing anything. On the other side, you have the completely unique temporary existence that sparks into reality the exact millisecond that environment is actively running. Reconciling these two, the eternal script and the temporary execution of that script, has historically been a massive conceptual hurdle. Section 2. The June 19th synthesis, a hinge in thought.
That brings us to a highly specific moment where this abstract dichotomy found a practical digital anchor. The profound simplicity of this realization is captured perfectly in an email from June 19, 2020. Kyle Smith wrote to Nolan Bass regarding a research proposal, stating, "I'll try to show how the code and runtime tree reflect each other so a developer can easily jump back and forth between the two types of expressions." That right there is the exact moment of the synthesis. Smith realized that if you build a system where the static code tree and the active runtime tree act as a literal mirror to one another, you achieve true philosophical reconciliation.
This realization directly inspired the founding principle of the Journal of Hecasitate Universali. As outlined in Volume 0, this synthesis acts as a profound JavaScript machina. It proves that the JavaScript environment, by operating as a runtime duration, mechanistically bridges the eternal algebra of the code with the highly unique, fleeting life of its execution.
Section 3. Inside the seed tree DB, the mechanics of reflection.
So how do we actually build this reflective mirror in reality? Let's dive into the concrete mechanics by exploring the architecture outlined in the seed tree DB patent, US 12 664142. The crucial takeaway of the seed tree DB architecture is that its nodes are incredibly dynamic. Unlike traditional databases where nodes just sit there passively holding information, these nodes are completely active. They co-locate both function and data properties simultaneously inside a script module. This means the script modules can interact directly with the live runtime objects. It creates a self-explanatory, active hierarchical structure that literally grows and breathes based on what is happening around it.
Section 4. Triggering the SMS event, spawning ephemera.
To really grasp this, we have to see the system in action. What exactly happens when the unpredictable outside world reaches in and interacts with this perfectly structured database? Let's walk step by step through a physical example from the source material. Imagine an external event, like a Twilio SMS text message, hits the system. First, this incoming communication is routed by an interface to a managing node. Let's call it a grandparent node in the tree. Second, the parent node receives the routed event and formats the incoming data, like the caller ID or message body, into a readable format like JSON. Third, the parent node literally calls a constructor function to build a brand new, temporary, timestamped child node using that data. And finally, the kernel steps in to dynamically link the new node's metadata right into the larger tree structure.
I want to emphasize the importance of what just happened here. That newly spawned child node isn't just a piece of data.
It literally embodies thisness. It is a time-stamped, discrete instance forced into existence simply by reacting to a real-world event. This momentary node represents the literal mechanical execution of fragility. It's the system catching its own fleeting, active state in real time and writing it into the very architecture of the database.
Section 5. The math of thisness. Log d of d equals n++.
But how does the system maintain its structural integrity when it's constantly spawning these temporary nodes left and right? To answer that, we have to look at the mathematical engine powering this dynamic creation. And honestly, this is where things get mathematically beautiful. Fundamental, unwritten JavaScript patterns like loops and nestings are addressed visually by recursive fractal square cells. What you're seeing is a representation of the base scale calculus mentioned in the journal.
When we pair those nested squares with a spiraling pattern, it brilliantly illustrates how this operates. The loops, the nestings, and the progressively shrinking scales define what's called a discrete logarithmic base scaling. Notice how the squares spiral inward, but crucially, as the text points out, they do so without ever hitting a vanishing point. They do not disappear into nothingness. This visual behavior is driven by one very specific mathematical identity, log base d of d equals n++. In this formula, the base d dictates a discrete resolution decay. It acts basically as a logarithmic lens. It maps the resolution of the data to discrete bit-perfect counting clicks, which is represented by the n++. This logarithmic scaling is exactly what gives that temporary database node its discrete, strictly measured thisness. It makes sure that every single event, like our SMS message, gets anchored to a specific, unique, countable coordinate within the digital universe.
This formula is a massive breakthrough because it creates what the texts refer to as a cork infinity. By using a specific mathematical area and finitude, instead of letting a geometric series decay endlessly into some imperceptible point at infinity, the digital ephemera hits a hard stop. It's firmly anchored to a stable, rational lattice, a physical boundary floor that the documents call the cork.
Section 6. Synthesizing the ephemeral, the macro view. Now that we've seen the micro level, how an external SMS spawns a node, and how logarithmic scaling anchors it perfectly in digital space, let's zoom way back out. Let's take these highly specific mechanical concepts and apply them to the macro view of computation. Check out this quote from theoretical physicist Stephen Wolfram from his Royal Institution talk. He posits that the universe itself operates on a hypergraph that is constantly rewriting its own structure based on simple rules. He says that progressive rewriting is the progress of time. Notice the massive parallel we've got here. Wolfram's grand vision of a continuously rewriting universe mirrors exactly what our dynamically growing seed tree database is doing when it processes an external event and writes a new node into its own existence.
We can visually anchor this grand idea using the diamond equilibrium chart from the source material. Within this framework, every new state, every single rewrite of the tree database acts as a tile. It perfectly represents the Russellian simple or particular. By strictly adhering to that cork to logarithmic math we just looked at, every new step is a perfectly balanced, forensically unique event. The system doesn't lose data into the infinite, it stacks it, perfectly bounded, frame by frame.
Which leaves us with an incredibly profound question to end on. We've just seen how a highly structured database can bridge the eternal universality of its code with the fleeting hectiadity of real-world events. So, if our digital systems are relying on this computational irreducibility and continuous, mathematically anchored rewriting to generate a record of time, does our physical reality compute its own existence in the exact same way? Thank you for tuning into this explainer. I really hope this leaves you with plenty to think about.